Parameters of instrumental analysis. In this technique, the methods, procedures, and protocols, accuracy, precision, sensitivity, selectivity, robustness, and rigidness, scale of operation, equipment, time, and cost, making the final choice, developing the procedures, calibration and standardization, sampling, validation, and protocols. Now, many students they have problem in the analytical chemistry. That is, how many students get precipitate of grammatical analysis. Then there is a degree of uncertainty. Some students get maximum precipitate, some students get minimum precipitate. Some of them did not get the precipitate. Now, there are many degree of uncertainty. That is, we are calling it is the errors. Now, in errors, whatever the errors we observe that now there are four examples given here. First example where the results are at the center and these results are very long from each other. In another cases, they are near to each other. Some results are very near but not accurate, and some results accurate as well as very clear and repetitive. Now, in such a type of cases where we can understand that the errors may be observed that with a low accuracy, low precision, or high accuracy, low precision, low accuracy, high precision, and high accuracy, high precision. This accuracy, where if we see the accuracy means here, if results are correct, then we are saying that good accuracy. Here, all results are same and they are accurate. Low precision means the results are very long from each other. Next, high accuracy means result are near to the this point, but they are same results with low precision. While these results are very near to each other, but not long from the center, that is long from the correct result, and therefore it is a low accuracy and high precision. But in this case, the high accuracy and high precision. Now, accuracy is the degree of agreement between the measured value and true value of the measurement. There are two ways to determine the accuracy by using the absolute and comparative methods. The absolute method and comparative method. Now, if we look towards this accuracy in terms of absolute error. Now, absolute error is the difference between true value and measured value. That is E equal to observed value minus true value. Now, for example, observed value is 5.7 ml and true value is 5.9 ml, and therefore the error, absolute error, is minus 0.2. While these errors can be compared with the other examples like relative error. The relative error is the ratio of absolute error to the true value. Therefore, relative error is equal to absolute error divided by true value into 100, it is in percentage. And therefore, for this same example, if we see the 3.389%, that is the relative error. Now, second example or second part, that is the precision. Now, precision is related to the method. Therefore, it is a degree of agreement between a replicate measurement of the same quantity. For example, reproducibility in result. That it shows the information about the method used for analysis. Now, it can be expressed in terms of deviation, average deviation, standard deviation, relative mean deviation. Deviation is the difference between the true value and observed value. But this is the deviation, these are the positive deviation. Now, if we look towards the deviation, it is a numerical difference between the individual result and mean or average value or true value. Therefore, it is denoted by in delta is equal to modulus of x minus x bar. Now, for example, these are the result. This is the true value average value, then difference between this and this is 0.2, 0.1, 0.1, and 0.2. Now these are the deviation, but if we see the mean deviation of the number of results, therefore it is average deviation. Therefore delta bar equal to delta 1 plus delta 2 plus delta 3 means addition of all deltas, then divided by number of the observations. And therefore total observed value for this example is the mean delta average deviation is 0.15. Now standard deviation, it is measured in terms of it is a square root of sum of square of deviation divided by the one less than the number of observation, and therefore s equal to, it is denoted by s equal to square root of the square of the all deviation plus we are adding all these divided by n minus 1, and from that we can calculate the standard deviation. And relative mean deviation, it is the average of the delta bar, that is a mean deviation divided by mean value or true value into 100, and therefore it can be calculated as a relative mean deviation is 0.88%. Now classification of the errors, if we see the systematic error, discovered error, corrected, eliminated, effect of result. Now the determinate error. Now this determinate error is classified as a operational and personal, instrumental, methods, and additive error. Now these errors, they are from the ourself. We can minimize easily by concentrating the experimental conditions and methods, selection of the methods. These errors, determinate error, can be minimized easily by correcting the by using the accurate procedure, and if you have any skill, then we can minimize these determinate errors. But indeterminate error, these are the random error, these are the accidental error. We cannot protect from that, and therefore we should know that what type of errors are there in the analysis. Now, in this case, if you see the sensitivity, if the two samples shows our ability to detect the difference. Now, this selectivity, it is related to the relative to the method, and therefore selection is most important. Now, in many analysis, we use two samples with a different amount of analyte. The selected method can be used to ability to detect the difference. Therefore, the sensitivity is measure of the method's ability. The second term is that the sensitivity. Now, sensitivity is the difference between the two results, but selectivity is a measure of method's freedom and interface as defined by the method's selectivity coefficient. Now, from this equation, that is a KAI equal to KI divided by KA, where I is the interferences and A is the analyte. And therefore, this can be in between the +1 and -1. And therefore, this method is more selective. Now, second term is that robustness and rigidness. Now, if you see that robustness, now this is many times what happened, the reliable results are there, but unfortunately there is variation, various in the physical and chemical interferences are there. Now, if the method is relatively free from interferences, then such a type of method is considered as a robust. Now, these physical and chemical interferences are there in many cases, and that can be minimized. Then we are saying that the method is robust. And second term is that the rigidness. Now we know that the reliable results, but unfortunately there is a variation in the experimental conditions like temperature, reaction time, pH of the solution, and it affects the on the result. If the method is relatively free from external condition, then such methods are considered as rigid. Now there are many methods are there. It shows the robustness and rigidness, and therefore results are more correct. But if there is interferences, then if you do not understand what are the interferences are there, then this random error or accidental errors are added and the results are wrong. Now in this case, if you see the scale of operation, now there are many methods are there. For example, in case of the weighing methods, there are many types of balances are there. Now when you are using the 1 gram of sample, then this type of balance cannot be used, because this is list count of this balance is just only the 500 gram, and we cannot use the 1 gram, 2 gram weight. For this purpose, we have to select the proper instrument, proper equipment. These equipment and measurements are classified on the basis of whether it is a micro level, whether it is a macro level, whether it is a meso level, or ultra micro level. On these cases, the what type of uh, analysis we have to select. Now, for example, if it is a macro level, then major type of analysis, analytical methods we have to select. If it is in the micro level, then we can use the minor level concentration of analyte should be selected. And if we are using the ultra micro, then we can use as a concentration should be in the trace amount, or maybe in the ppm level or ppb level. Then it is called as ultra micro level analysis. Now, in this way, the scale of the result we can utilize by using this graph. Here, from this to this level, if we use the macro level, then we can use the major concentration. That is, the concentration of analyte should be 10% to 100%. Above 1% to 10%, we can use a 10 raised to minus 1 to 10 raised to minus 2 level. That is, a 10 milligram sample can be used. Then it is called as a meso level. And from 10 raised to minus 2, that is a 10 milligram to 100 micromilligram level, then we can use the minor research or minor concentration. It should be in the 100 microgram to 10 milligram level, and this is called as a micro analysis. And we are saying that it is a minor concentration. Now, below that, from the 100 microgram, if we are selecting the sample, then it is called as ultra micro analysis. And for this require the trace amount of sample. And if we use a very trace amount, that is ultra trace, then ultra micro analysis up to the below than the 1 microgram, we can select the sample. In this way, with respect to the scale of operation, we can use with the help of this standard graph, we can use the analytical method. Now, for example, in case of the weighing, the for micro level, we can select the balance for weighing as in the micro level of the list count level, the below 1 milligram or 0.001 milligram list count. Such a type of things can be utilized. Now, in case of the selection of the equipment, time and cost, in case of the method, that is selection of the method and equipment, it is most important, because once you select the method, then it is important that the equipment required for this method and how much time required for this analysis, even that the cost is also important. Therefore, selection of method is important, equipment is important, time required for the analysis it can be considered, and cost of the chemical per sample is also important. And then a final choice for the method and selection of the instrument is related to the whatever the method we are selecting, it should have a minimum errors to get the reliable result. And this method, selected method, should be a cost effective method as well as the time consuming, required the time consuming. Now, in case of the developing the procedures, the first step is the selection of method. Now, whether if it is a qualitative method or a quantitative method. If it is a qualitative method, then for inorganic qualitative analysis, organic qualitative analysis, or general analysis. But in case of the quantitative method, there are many quantitative methods are there available. It can be choose on the basis of the whatever the quantity of the sample. It is a major, minor, or ultra micro level. That method we can select, and this gives the better result. Then selection of the procedure, because there are many procedures are available. It depend on amount of compound and the method of selection of the method. Therefore, procedure should be selected with important or it can be used for the to get the reliable result. Now, after selection of the procedure, we can calibrate the when if it is an instrumental analysis, then we should be calibrated. Calibration is required. Now, for this calibration, we require the comparison for it may be a standard standardization of the method or standardization of the instrument. And for sampling, whether the sample is solid state sample, liquid state, or gas state. Now, these samples can be converted from solid to liquid, liquid to gas, or gas to solid, or gas to liquid. Now, what type of solid sample is required according to the selection of the method and equipment, we can sampling should be as per the requirement of the method. Now, in case of the sample, there are many types of sample like gross sample, annulate sample. Now, we are not taking the whole sample for the analysis. From that, we can select the gross sample, and from that, the analytical analyte sample, because it required every part of the sample represents the whole body, and therefore sampling is most important. According to this sampling procedure, we can select the sample, and after that, the validation of the result, because whatever the results are given out from the uh, sample this analysis, it should be a validation, because whatever the validation is the process where verifying that a procedure is acceptable result, it must be capable to producing the result and acceptable accuracy and precision, and therefore the whatever we are selecting, this can be transferred into the data, and data should be validated in the final step. Now, after developing this procedure, then we can use the protocol for the analysis. Means in many industries where protocols are used, for example, this is a simple protocol. For example, once you decide the determination, then method can be selected for this analysis. After that, the method should be documented, because we can write the procedure, and from that procedure, we can use the standardization method. When it is the instrument or method, we can standardize with the help of standardizing procedure. Then establishment of the QC, that is a quality control. Whether whatever you are doing, its quality should be controlled by the standardization. And after that, we can write the control chart. Whatever the controls are there, means whatever the external conditions we have to maintain, on that the control chart should be there. And after that, the internal calibration verification, then internal calibration blank solution should be calibrated properly, and then we can use this method to run the sample, that is a result. After that, the calibration of and verification should be there, and if they are corrected, then data transfer to the validation. If it is not correct or wrong, then again we can use the standardization procedure, and this can be utilized again, recycle. And therefore, after validation, the sample can be utilized. Now, in this way, we can observe that some protocols are there, and in that case, in parameters of the instrumental analysis, where high accuracy, high precision, the sensitivity should be considered, the selectivity which considered, and method should be the robustness and rigidness. And under the scale of operation, we can select the method and equipment. Thank you.